So what I've looked at so far is the fact that accuracy and precision are often interchangeably used, but they're not the same thing. Accuracy is how close to the actual result are we getting, and precision is how close are our results to each other. Clear? We used the dartboard analogy. I had an issue with the dartboard analogy. What was the issue with the dartboard analogy specifically for accuracy? What was the problem with that? Yep.
There isn't a process, you just throw the dart.
Yeah, and you can see exactly where you're aiming, okay? With a gun, what do we get? What's involved specifically with the scope?
That shows you.
Well, if you look in a scope and try and shoot at something, does it actually always go to where sometimes it's higher, sometimes it's lower, okay? That's a better representation of accuracy because you need a sight in your scope. Does that make sense? Okay with that? Okay. So how do we deal with it? Because it's all well and good to say this is what they are. How do we deal? So I want you to write down, how in science can we deal with issues of inaccuracy? So how can we fix up inaccuracy? I want you to think about what accuracy is. How can we fix it up? So if we've got results, so say we are consistently hitting off to the left over here on our dartboard that's still thankfully visible. If you were playing a game of darts, how could you fix that up? Have a think, give you 10 seconds. Liam, what would I do if I was playing a game of darts and I was aiming the bullseye and I just kept going up and left? What would you do?
Adjust and try to go a bit more.
So I'll probably aim over here instead, and then I'll get the bullseye. Does that work? Does anyone know what we call that? You're right, we've got a specific name for that though. It starts with C.
Compensating.
Compensating is not a bad guess. It's actually reasonably good guess, but it's not quite the word. Because we are compensating for our misses, you're right, but there's a special word we use in stock. C-A-L?
Calibrating.
Very good. I'm going to calibrate. Which is just shifting our equipment or target. Okay, easy enough. What's the challenge with that? I say easy enough, what's the challenge with that? It's hard to calibrate because we need to often know where the accurate result is. So it's easy when we know where the result should be, not easy when we don't. Okay, let's say, and this is probably more relevant to our high school scenario, because we're not spending lots and lots of money on our equipment. We're doing things like using stopwatches for mousetrap races, or putting temperature probes on stakes, for example. So we often have accurate results that are accurate but not precise. How can we fix up a set of data that looks like? Now if I wanted to hit the target, if I wanted to hit the bullseye 100 times or get a bullseye, what could I do? If I wanted to know where the bullseye was, or where I was aiming, see where I'm aiming, what could I do?
Go for the middle point.
Yeah, what do we call that? You're right.
Yeah, for
Taking a midpoint, taking in. What do we do in science when we take lots of trials? We take an average. We take an average. So we can fix inaccuracy with many trials and averages. You with that? That's a summary on what accuracy and precision are and how we can go about fixing those problems. Any questions on those? Pretty exciting stuff, I know. Let's talk about uncertainty.